So today I'll be talking about software supply chain security and package manager security, specifically attacks that are stemming from these package managers and how we've developed tools at Oscillate to tackle these attacks using Packj. So a little bit about us. I'm Devdutt. Ashish is not here today, so I'll be representing two of us. We're both Georgia Tech alumni, and I think thanks for the introduction. You can find us on LinkedIn on these URLs. So basically at Oscillate, what we're doing is we're focusing on building tools to mitigate software supply chain attacks. So open source software is everywhere, as we know. As they say, open source software is eating the world. I think over 90% of Fortune 500 companies use open source today. And I think there are different studies, but on average, the verdict is that more than 75% of the code that companies today maintain comes from open source. So as you can see, if there are developers here in the room who use JavaScript or Python or Ruby gems, there's about most of the open source that is being consumed to build the internet or machine learning applications, it's coming from these package managers where this open source is hosted. So we have a node package manager, which is NPM and PyPI for Python, and Ruby gems for Ruby on Rails. So as you can see, there's millions of packages out there, and open source is distributed through these package managers. So there's about 1.6 million NPM packages, about 400K, 350 odd from Python, and about 200K from Ruby gems. So as you can see, the open source is here to stay. It's massive, and it's everywhere. So as we briefly discussed, the open source is hosted on these package managers, and that's how we, as developers, we reach and download these packages and include them in our software to use them, right? So what package managers have done when they started to build these package managers, the people who built these, like NPM and PyPI, they made these package managers very easy to use. And anyone could publish a package. There's very, low friction, single command publishing. There are things like two-factor authentication, but generally what's observed is that developers don't, for not the right reasons, but they don't end up using that. They want an easy way to publish a package, right? So you or me could write a package. We just follow a README, and within 5 to 10 minutes, our package is up there and ready to use, and people can really download it. So as you may have already figured out, it's easy to publish packages for other people to use in the open source domain, but there's limited security vetting. And just to give you a statistic, like every day on NPM, there's about 20,000 packages just being authored and uploaded. We're not talking about downloads. There's about 1 billion downloads that are happening from Node, right? So just 20,000 authors are publishing their packages to use. So all the software that we use on our servers, desktops, laptops is essentially written by volunteers whom we don't know, but we trust. So this picture kind of demonstrates the phenomenon. So this is our modern digital infrastructure, and then we have this this is like a package that is being maintained by someone, and as you can see, it's basically holding up the whole structure, and if anything bad happens there, it could bring our modern infrastructure down. So, as I'm building up to the story, you can see that as there is a good faith of, building open source and making it available, there's also bad actors that want to exploit the trust that we are putting on the open source community, right? And this is just a snippet of some of the attacks that have happened over the last 2 to 3 years. Last year, the supply chain attacks tripled. And even this year, through the first 8 months, 9 months, this year, every month there's been at least 1 or 2 attacks on the, and all the package managers, right? None of them have been spared. NPM, Ruby Gems, PyPI, you name it. So that explains kind of like open source is everywhere, but then there's the way they're hosted, they're not very secure. Now there's another problem in the way that open source packages are being used, and that's the phenomenon of dependencies, right? So anyone who's a JavaScript developer in the room knows that, like essentially when you download a package to use in your application, it brings down with it about, on average, GitHub found that there are 10 direct dependencies that come with it, and those are just the direct dependencies. There are transitive indirect dependencies, and each one brings around 7. So essentially, it adds up to about 700 dependencies that get built into an application that you're writing, which is of a reasonable scale, right? So any mature JavaScript application essentially has about 700 indirect and transitive dependencies. For Python and PHP, it's a little smaller, but still it's about 70 for those two, and Ruby has about 68. And Synopsys did an audit, and they published that an average application, which is a commercial grade web application, has about 528 dependencies. So all of this combined, basically what it means is that we're using a lot of open source, and each time we pull open source, there's a lot of dependencies that come with it, which means the attack vector to exploit the supply chain of the open source that we're using is pretty big, right? So one could get in, if a bad actor wants to get in, they have multiple attack vectors to get in and sabotage these packages. So this is what a basically supply chain attack would look like. The bad actors would target the least secure in the supply chain, and the main thing about supply chain attacks is that this is not like, I think we know about bugs that we introduce or the CVEs, but supply chain attacks essentially are the bad actor would inject harmful code purposefully, right? So it's malware, unlike CVEs, which are like accidental programming bugs. So those we know that everybody knows about CVEs, but this is code that is intentionally stealthy and evasive. And it cannot be easily patched because essentially once malware is in the system, you really have to figure out how do you make sure that you understand it fully, and then just patching it will be hard because it's an unknown bug. So it's not a CVE that's known and it gets exploited, so then we'd have a patch available to push through your IT policies. And because of what I explained, how large how much open source is being adopted, the blast radius is pretty large, right? If there's a malware that gets in, it's potentially from thousands to millions of developers could get hit by this attack. So we've covered kind of the story behind why these attacks happen and what's the dangers behind it. Now we'll go into a little bit of detail on the attack techniques that we use, that are used. So there's this common thing called typo-squatting, right? We're typing a message, we make a mistake, and the message goes out. And we do it so often. And there's the same, it doesn't change for developers who are trying to install a package. Let's say you do an NPM install or a pip3 install. So some of the exploited behaviors are misspelling, where the actual package name is, say, Colorama without a U, but then somebody types in OU, and then it brings down, someone's uploaded a malicious package called Colorama with a U, and then it's going to bring down that package, and it's going to install it, and it could be malicious. And then there's order confusion, which is like, instead of nmap Python, which is like the original package is Python nmap, the developer could use nmap Python by mistake. And then there's another type of attack called separator confusion, where the original package is easy_install, and the developer will use easy install as a single word. So what this does is it downloads the malicious package here, and what the bad actor would have done is they know that these packages exist, So they create packages which are very close to the spelling, the correct spelling, and they upload it to these package managers. And invariably, it might seem like, oh, who's going to make such a stupid mistake? But even until the last 2 months ago, there was an attack that exploited typo-squatting. So this is an example of a typo-squatting attack. So there was a well-known package called MITM proxy. So someone uploaded a package called MITM proxy 2, hoping that, because it is like a 2 added to the original package, someone without experience or, a developer inexperience or a typo may think, or someone who goes and searches for MITM proxy, they'll find this MITM proxy 2, and they may believe that it's a new version. And what they did is, essentially, it looks exactly like the original package. So the project description, and all of it is exactly the same, except for the fact that it's a whole different package with malicious code inside. Right? And what the code does is, essentially, it removes all the safeguards that were there in the original package. So a deny is removed, and then some additional access control is allowed. So this essentially allows anyone on your network to execute code on your machine with a single HTTP request. So this is an example of someone who did this, uploaded MITM proxy 2, and this could run in, like someone would, by mistake, using a typo-squatting mistake, would download this malicious package. So we covered typo-squatting. The other technique is social engineering. So there was this popular package called event stream, and what the attacker did in this case is that he built a rapport with the author of the package for many months, and then at one fine day, they volunteered to maintain the module. So as this message says, he emailed me and said he wanted to maintain the module, so I gave him access, right? And then before, in a few days down the line, the person who got access uploaded some malicious code, and that got checked in, and then that led to an attack. So another technique is called dependency confusion. Now, this has been exploited in the past, may not be so much today because we have seen it in the past, and perhaps some of it has been fixed, but it's important to discuss this attack. Here what happens is your CI/CD, which is your production server, typically uses something from your internal. So let's say an organization hosts known good packages with a certain version, which is 1.0, but the tools that actually put your builds together, they have some options where if they were turned on by mistake, there would be another later package available on a public repository, let's say on NPM or PyPI. So it turns out that the external package version is higher, so the tool goes ahead and downloads the newer version, but someone actually uploaded a malicious package with a higher version number, right? So this package 2.0 is essentially the attacker doing bad things, uploading it there, and then your CI/CD pipeline pulls in the malicious package and ignores the internal package, and that goes through into the product. So another technique which still happens to this day, like there was an attack on PyPI just in I think it was August this year, which is called account hijacking. So in this case, the reason for this is many times there are people basically have an email ID which gets taken over because they don't have two-factor authentication. So one can say forgot password. If there's a way they can impersonate your email ID, they get access to your account, and that's how someone could take over an account. I'll go into some details on another attack and the steps that this would take. But yeah, so it's important to remember this technique. So we covered all these techniques on how one could potentially gain access to these packages. So how do we defend against these attacks, right? So the straightforward answer is maintainers and package managers need to be more responsible, and you enable two-factor authentication. You have better name scoping to avoid typo-squatting, and you have package signing, so that you know that it's a known signed package is being uploaded and then downloaded and used. But there are scenarios that these methods or these mechanisms won't work. The example being that if there is a developer who decides to go become a rogue developer, right? Like this has happened more than once. It's actually, maybe half a dozen times where someone's not happy about maintaining a package and they turn into a rogue developer. There was one instance where the colors package was sabotaged by its own maintainer. And in the left pad example, someone just took down a package that was commonly used by millions of developers. So that can be causing a wide impact. Right, so how do you protect against these kind of attacks where, like let's say I'm a good guy, but then I decide overnight I want to do something bizarre, right? So I have all the control, I can do whatever I want, and then the community has to pay a price. So essentially what this then boils down to is the developers and enterprise organizations take ownership of, if they're consuming open source, they need to be more wise and prudent when using open source, and essentially analyze the package code and behavior before adoption. And then the other way would be to use pre-vetted packages, where they use tools to create a repository of well-known pre-vetted packages, and they wouldn't pull stuff from the internet or open source package managers, but would use their own pre-vetted packages, right? So originally it comes from open source, but then it's you run through a bunch of tools which make sure that the package code is good, the behavior is fine, and then you add it to your list of pre-vetted packages which you use internally. So if you were to go down this path and consider vetting, right? We agree that vetting is the way to go for organizations and developers, but we talked about dependency, and we talked about the problems about how large these dependency chains go. This is just an example that if you were to sit and manually vet this dependency chain, this is the well-known PyTorch package. This is just showing dependencies to an order of 2. So if you go further, it's like this graph can get ugly, and as you can see, there's arrows all over the place. So auditing this manually is just infeasible. And if you were to look at existing tools out there, a lot of tools will tell you, okay, here's this package, and this version, it has this known CV, right? So people know about, so Sneak Advisor is one that's commonly used, but essentially what they're talking about is no known security issues. Now there's an example of this package which, if you look at the code, essentially it's glaringly malicious. It's doing stuff where it's accessing your SSH keys and trying to send it out. But Sneak Advisor tells you that there's no known security issue. And this is accurate technically because there's no CVE or known vulnerability, but unless you do a deep code analysis in this package, you wouldn't know that this is a glaringly malicious package. So there's a lot of tools out there that focus on known vulnerabilities, but there's not enough out there that detects malicious or malintent in these packages. And another way that developers generally tend to rely on is basically, okay, you find a package that kind of sounds like what you need, it has the right functionality, so then you look at its reputation. Now here you can see that this is a sandbox package. It claims to do something, and it has a 4,000 stars and a bunch of more than 1,000 forks. But it turns out that it's actually using a technique called star jacking, where all it does is it basically, the GitHub link is pointing to another project which has a lot of stars and forks, and there's no verification that the Python PyIndex does to stop this kind of basically this attack is called star jacking, right? So you took away stars from somebody else and you're trying to show the reputation of your package as being very healthy. So vanity stats are not enough. We know that there's tools that only focus on known vulnerabilities. So that's where Packj comes in. So this is the tool that we've been working on for the last year. It's a developer-friendly vetting tool. It takes a zero trust approach to automated vetting of risky code and attributes and packages. And it provides actionable security insights. So things like, is the package old or abandoned? This is very important to know because if the package is abandoned, it's probably going to have vulnerabilities and nobody's there to fix or support this package, right? And does the package read files or send data over the network? Is it reading your SSH keys? Is it doing looking for Bitcoin addresses? Things like that. Now, you might, so many times, so the way these package indexes are is that you can, these are runtime interpreted languages. We're talking about Python and Node.js. So you don't actually need to have a GitHub. You can just upload a package and you don't need to have a GitHub. But what our tool does is it basically makes sure that if there's a package on the repository, if there's a package on this package registry, is there a corresponding GitHub repo that backs this package, right? Is it available publicly? Other things like, is the package trustworthy? Have there been a number of versions released, right? And what's the release history? How often is the package getting updates? Is the author of the package trustworthy? Does he or she have a valid email? So these are metadata metrics that are important to ascertain that the package is healthy. So we've built this tool. It's a command line tool, and it's also customizable to your threat model, so it will reduce alert fatigue. Like you may, for some developers or organizations, it may be okay to use a package that's, let's say, 1 year old. So you can set that to 365 days or 1 year, and it won't flag that as a malicious package. So essentially what we do is, using Packj, we look at each package that we're trying to download, and we validate the email of the maintainer. An invalid email may suggest that there's no two-factor authentication. And if you want to be sure that the package is protected against account hijacking, the email ID must be valid, right? So we do those checks in our software. We make sure that the package is not old or abandoned. So we detect that. Basically look at metadata. When was the last release? Was it like 2 years ago? Or is there no update? So there's been a slew of updates, and then at a certain date, there's nothing, no activity on the package, which means the package is essentially abandoned. So the risks basically are that it won't receive any security updates or fixes. And if you know the metadata about the package, you can also look up whether there are any unpatched vulnerabilities in there. There's not going to be any updates to those because the package has been abandoned. So these are the risks that you become aware of. Presence of public source code repositories. This basically we use a technique called for provenance, where we look at the code inside the package and the GitHub repository to make sure that there is a match between the two. So that gives us provenance confidence. And then, as I mentioned, there was an attack called starjacking. So if there's a package and there's a legitimate GitHub repository, and if the description and the code matches, then it's not going to be susceptible to, or it's not doing a starjacking attack. And then we do protection. We basically detect typo-squatting, which means if there are 2 or 3 packages that are very similar, name sounding, the name sounds very similar, we can do distance-based methods to detect that which one's legitimate and which one's a typo-squatted package. Because one of them would have a good reputation, a lot of downloads. The other one would be like this new package that doesn't have any downloads, right? So that's the metadata analysis that we do. Then we also do static analysis, where we use the AST from the language runtimes to determine whether the package is doing anything sensitive, like opening or reading or writing files, doing any network activity, like sending some credentials out to another application, and whether it's trying to. So some packages, they download a payload from another URL and they try to execute it in a separate process. So those would be flagged under exec, eval, or fork APIs. So basically, we do rigorous API analysis, and if any of these are found, we flag that for the developer to further investigate. So in addition to doing metadata analysis, static analysis, we also do runtime analysis to detect attacks such as protestware. For example, we compare the prior and current versions using dynamic traces, and if we see anything that's suspicious, that's significantly different, that could be flagged as malicious behavior, right? And the runtime analysis further improves detection accuracy because it uses both static and runtime and introduces false positives. Runtime analysis also helps us to determine platform-specific behavior. So sometimes a package looks just fine on Linux, but on Windows it may exhibit a certain different behavior. So that's a little bit about the tool. So this is an example of a remote code execution attack. This was a package that we found on Python package registry. So as you can see here, essentially what it's doing is it's reading a payload from this URL and then writing it to a file, and then it's trying to launch a separate process with the payload, right? So this could essentially be a bunch of things that could run as a process that goes and reads files, looks up your SSH keys. Any of that could be in this downloaded payload, which the payload obviously is not visible here, but the mechanism is clear for us to see. So this is what we found. This was a package that was uploaded on PyPI, and it had a few downloads. So we looked at it, and we reported this to the package managers on PyPI, and then they took it down. So I think we've gone through what some of the capabilities of our tool. Now I'll walk through some of the attacks that we've found or we've come across in the last few. I think this one's the oldest, but some of the others are more recent. So if Packj was involved in the detection, how it would have avoided this attack, right? So this is a dependency confusion attack which happened in February 2021. So essentially, as the image shows us, the internal version had a version 1.0, and then the hacker uploaded a higher version on the external repository, and JFrog Artifactory, which essentially is the tool that's looking at what it should do, is confused because it sees that the internal is 1.0, but the external is a higher version. So there was a default configuration in JFrog which would always prefer the higher version, and therefore it goes to the external package when the external package is actually malicious. So the method used was create a new malicious package, the higher version. And this is a bit old, but the person who did this, they were able to attack companies like Apple, PayPal, and Microsoft, and they did it in an ethical way, so they got their bug bounty thing. But if Packj was used in the detection, it would have identified, because the way name squatting and this attack was done is basically it just imported the original package and it didn't do anything much, right? So essentially the lines of code in this new version 69 was very, very small, right? And there's no public GitHub repo that was found. So if they use Packj, our tool for a protection, they would have detected this attack. So this one's more recent. It's called, it's basically the CTX package hack. This happened in July, very recent. So this one's particularly interesting because even today there was a research paper that came out. It said that there's about 2,800 or so accounts packages that have an expired email account. So there's still a lot of accounts out there that have email accounts. There's still packages out there that have expired email accounts that could be exploited. So in this case, what the attacker did is they used a bot to scan Python packages and check for expired email domains. And once they found one, they just bought a domain for $5 and created an email ID associated with that domain. And then they just hit forgot password, right? And then they got an email to take over, and you change the password and essentially take over the package. And then the attacker went ahead and published malicious new versions as well as replaced the known good versions. So, and then what this malicious new package or the replaced package did was would steal your AWS credentials and send them over to a remote Heroku app. Now, CTX turns out to be a very popular package, which with over 22,000 weekly downloads. So within 3 days of when this package was up there were 7,000 odd downloads of the package. And then the person who did the attack came out he wrote a Medium blog and explained, that he did this and some reasons why. If the package tool was used for detection, then we would have immediately detected an expired email domain, and we would have this package was essentially 2 years old, so there were no updates to the package for 2 years, and then suddenly someone uploaded an update, right? So that's an anomaly. So our tool would have detected that. So the package was over 2 years old, and then we would have detected using our static analysis, we would have detected the suspicious API calls to send messages to a remote server. And then this one is basically the colors and faker attack. Now, the reason why I'm covering this is essentially this is an attack where it's just a person who decides to protest against something, right? So it's a person who's been a good developer, a good Samaritan, or a good citizen for most of their tenure as an open source developer, and then they are unhappy about maintaining software, not getting paid well, compensated well enough. So they essentially sabotage their own package, right? So this is an attack that you really can't use any other means to detect, even if we use two-factor authentication, the signing of packages, and all of those methods, right? So what the developer did was added an infinite loop to colors.js that printed garbage, and so faker.js used to generate data. It used to generate artificial data that was used in a lot of experiments, and what the attacker did is they started to generate corrupted and bad data. So it broke a lot of applications. As you can see, colors.js had 23 million downloads a week, and 19,000 dependent projects were using it. Similarly, faker.js had 2.4 million downloads a week and around 2,500 dependent projects. So if they would have, if the developers would have used our package tool, our static and dynamic analysis would have detected these infinite loops and then alerted them that, hey, something's broken, so don't use this particular version. So that kind of covers some of the features of the tool and where it can be useful and what attacks it can prevent. So we'll go to a quick demo of the tool. So I'll basically use it on two packages, and I'll kind of try to show what's interesting about. I think it's a little bit on the side. I'm not sure if everyone can see, but I'll probably talk about it. So first we'll audit an NPM package called Browserify. So we'll look at the metadata to see why it's interesting. So as you can see, we're running the package tool in a Docker container, so it's kind of sanitized and containerized. There's no risk of running this on your machine because it's running inside a container. So as you can see here, this Browserify package actually has 2 million downloads a week, so it's really popular. But it has an expired email domain, right? So that's a big red flag because someone could potentially buy a domain, at whatever that can be purchased, and then substack.net could be purchased, and then an email ID could be created, and someone could take over this package. As you can see, it still does 2 million downloads a week, but it's vulnerable to an account hijacking attack. And it has, and some of the other metadata that we flag about is that we found a lot of dependencies. So that's generally something to look at. Why the package has a lot of dependencies. You might want to look at what you may want to vet these dependencies themselves to see that whether it's a healthy package or not to use in your software. So that's a NPM package called browserify. Now we'll look at a Python package called request with a version 2.18.4. So this is a slightly older version of this package, but why it's interesting we'll see in a moment. So the tool basically looks at all this metadata, and it'll check the home page for validity. It downloads the package, and then looks at the static analysis of the package, and then provides a report. Now here you'll see that this is an older version, and it actually has 2 CVEs, which are known vulnerabilities, but it still receives 55.7 million downloads a week. So for some reason, developers still have not upgraded to the latest version, even though this is having 2 known CVEs, and it's a pretty old version, right? So this is, again, trying to show that as developers, we're not doing the due diligence and not upgrading to the new packages, the new versions of packages, in spite of the fact that there are vulnerabilities in this package version. So our tool comes in 2 flavors. One is what I just showed you was the standalone tool. So we also have a thin client, which is like a client that runs on your machine, but you hook it up to a cloud SaaS service. So I'll demonstrate that in a minute. So we have what we basically call as package.dev, which is our cloud counterpart to the standalone tool. And here you can create an account, and it's a free account. You can log in, and you can actually view and search for a lot of packages here and get detailed reports on each of those packages. And as you can see, we ran a scan on date utils. Now I will show you. So this is the one that shows up at the end in September. I just ran this scan using the thin client. And so we can look at this report. So what's interesting about this package is that it's used quite a lot. It's got 45,000 downloads a week, but it has a bunch of things that are suspicious, like it has an install hook. It hasn't been updated in a long time, and it doesn't have that many releases. So it's essentially pretty much an abandoned package, but it's still very popular and it's used a lot. And it has some weird things that you might want to go and look at. Essentially, it's running some hooks at install time, and then there's some other sensitive APIs that it calls, right? So we have this we have this SaaS API called package.dev. That's we have our GitHub, which is available here. So this is the standalone version, and we're getting good traction from the developer community. We have about 200 plus stars, and this GitHub it basically explains all the features of our tool. And essentially, you can please take a look, and it explains the features, how it works. We're also adding a new sandboxing capability that I didn't talk about today, but it's up and coming, and it's work in progress. And then this is the tool that is powering our the SaaS service that I talked about. So this would be, so we basically we're opening this up to developers and enterprises to the SaaS API version has a lot of detailed reports, and it'll help security audit teams to look at what a package health looks like before it gets adopted for use within the organization. So I think that's pretty much what I had today. I think we ran through we went through the website. So just to add that the cloud-based SaaS functionality. It brings us, premium features like provenance detection and typo-squatting support. You can customize your alerts and thresholds for like how old would you be okay for a package to be. Those kind of settings can be customized, and then it uses advanced techniques like deeper longitude, like it does deeper historical analysis of code and longitudinal analysis of several features to do anomaly detection, because we have more compute on the cloud, so we can do all these advanced mechanisms that provide us more accurate data. It saves compute and space for end users because you're not downloading the package and scanning it on your computer, but it's being done on the cloud, and you can just look at the report if you need to. And and then more advanced, more detailed reports like dependencies and dependence, detailed code analysis, and direct pointers to suspicious code, as I showed you. You can link to the GitHub directly from the web portal, and it'll show you what line of code is looking potentially interesting or malicious for you to audit. So lastly, basically, we reported some of our findings to Python package manager maintainers. So these were the packages that we reported. So we reported about 40 malware, packages that were malware. And our website has, if you go to packj.dev, which is our website, you'll find our blogs on each of these packages. And we reported these, and they have now been taken down by the Python maintainers, the package PyPI maintainers. So yeah, I think we're about time. That's pretty much what I wanted to cover. What I wanted to cover. This is our GitHub. Basically, our company has the Oscillate GitHub, and then package can be found there, and packj.dev information can also be found there. And this work is powered by Oscillate. Thank you.